Hello everyone. Welcome to the solution of LeetCode problem 283 named move zeros. In this problem, we are given an integer array nums and we have to move all of the zero to the end of the array. And we have to maintain the relative order of the non-zero elements. That means we cannot change the order of the non-zero elements. Here, we have to solve this problem without making a copy of the array. That means we cannot make a copy of the current array. Now in the first example, the array contains 5 elements, which is 0, 1, 0, 3, and 12. And if we move this 0 and this 0 in the last positions, then the array will be 1, 3, 12, 0, 0, where I maintained the relative order of the non-zero element, which is 1, 3, and 12. In the constraint here, the array length can be in between 1 to 10 to the power 4, and each of the array element can be in between 2 to the power 31 to negative 2 to the power 31 minus 1. I hope you understood the constraint. Now let's move on to the solution. We're gonna solve this problem by using two pointers algorithm. Here, at first, we will take one pointer x, which will point to the first index, and we will take another pointer I, which will point to the first index as well. Now, the basic intuition of this problem is, instead, we have to move all of the 0 to the end positions. We will try to put all of the non-zero element to the first positions. So the algorithm is, in this problem, we're gonna move the non-zero element to the first position. Suppose if we move this 1 here, this 3 here, this 12 here, then if we make the remaining element 0 and 0, the array will become 1, 3, 12, 0 and 0. So this is the desired output. Now let's see how can we solve this problem by using the two pointers algorithm. Here, at first we will take one pointer x, which will point to the first element, and we will take another pointer I, which will point to the first element. Now we have to check whether the value of AI is non-zero or not. Here, the value of AI is 0, so we don't have to do anything. Now, our I is pointing to this element 1, which is obviously greater than 0. That means here we have to put the value of 1 into the first index, which is here. Now, as we have pointed the value in the first index, so we have to upgrade our pointer value x. So now our x is pointing towards the second index. Now, currently our I is pointing to this element, which is equal to 0. So in this case, we have to do nothing. Now again, currently our I is pointing to this element, and which is 3, which is obviously greater than 0. So we have to put 3 into the x index, where we have to put 3 here. Now our x will point to this element. So far, so good. We have taken the first element is 1, the second element is 3. Now our I is pointing to the last index, which is 12. So currently our x is pointing to this index. So here we have to put 12 into this index, because 12 is obviously greater than 0. So now for the third index, we have taken the value 12. Now we have to upgrade our pointer value x to these positions, and we have to upgrade our pointer value y to these positions. But wait, our pointer value I became out of bound. So now the algorithm is, we have to put all of the remaining elements of x index and make all of them 0. So this is the basic algorithm. After that, making all of the remaining elements 0, we will find the array will be 1, 3, 12, 0 and 0, which is the desired output. I hope you understood the two-pointer approach of this problem. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named move zeros. The parameter of this function is the input array. And we are taking one pointer, which is x. Currently, it is pointing to the first element. Now, we are making a loop from 0 to the end of the pointer. And we have to check whether currently our value is not equal to 0 or not. If our current value is not equal to 0, that means we have to assign the respective a of I or the respective element to the x pointer and increment the pointer value x. After that, if we have remained in any of the value which is greater than x, for those value we have to assign 0. After that, the input array A will be in the desired order. I hope you understood the algorithm. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n, where n is the size of the input, and the space complexity is big O of 1 because we are using only constant extra spaces. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.